But this is what kind of equation? It's quadratic, so our first question is whether or not there's a bx term. What do you think? Yeah. Okay, so then we're going to try to factor. What if we can't factor? What do we do? Well, we need to do that anyway, so let's do set equal to 0, so we need to subtract 33n. Do we have any like terms for 33n over on the left side that we can combine it with? No? Since this n doesn't have a squared, it's not the same. Okay? And then from there, I almost wrote the wrong thing. What should we try next before we get into the factoring? Remember GCF? Is there one? This one doesn't have one. Okay. And then we'll get to the star. So again, what if star won't work? Did you guys ever learn quadratic formula? That would be your next tool. All right, what is a times c in this case? Negative 70, what's b? Negative 33, a is 14. That's kind of a weird a value, huh? We haven't had too many big a values. All right, so factors of 70 that add up to 33. This would probably be a good example to just go through your list and do your best to get all of them. So start with 1 and 70, and then 2 and 35. 3 doesn't go into 70. 4 doesn't go into 70. 5 and 14, that's how we got there. 6 doesn't go into 70, 7 does, 7 and 10. But we already kind of passed it. So 8, 9, 10, and then we're cycling back. So anyway, 2 and 35. Which one of those needs to be negative? The 35. So the bigger number always matches the sign of b. Okay? And then we see if we can reduce either of these. This one does reduce. So 2 goes into both of them. So we'll get 7x plus 1. How about 14 and 35? Does anything go into both of them? Yeah. 7 does, actually. So we get 2 and negative 5. Okay. Alright, so there's the factored version. And I do want to remind you, if you forgot to reduce, that your solving answers will be the same, but your factors will be wrong. So it just depends what you're being asked to do. Okay, from here, what do we do next? We have two factors, something times something equals 0. Yes, this is that whole take each one and set it equal to 0 thing. So negative 1, 7. Over here, you're going to get x equals 5 halves. So add 5, divide by 2. Did anybody get both of those? Okay. Anybody get either one of them? Hmm? Oh, brother. That doesn't count. Okay. Well, we'll keep reviewing this. This is a really important thing to be able to do. So grab your packet from yesterday, and go back and review the exterior angle stuff. This will be the last day of angles, and then the rest of the unit, well, I should say the last day of specifically angles. And the rest of the unit will be focusing on individual quadrilaterals only, not polygons in general. Alright, so exterior, remember we showed that the total is always 360. So there's no figuring out the right side of this equation. And then if we have a regular polygon, we just divide 360 by how many sides we have to get the angle measure for each one. And then we did this example. So we were given two of the angles, well sort of given two of the angles, which were 5 and 4. And then we just had to do some kind of relationship between these other three. But really the whole thing boiled down to total equals total. And we just had different expressions for those. So the total angle we knew was 360, but how did we get that? Well, we added up all the pieces. And we've seen that now pretty frequently, right? Okay. So let's just do an example or two of this, and you can try to write it if you want, or you can just follow along up here. You'll get some practice with it. So it starts giving us some angle expressions. What should I do with those? Yeah. I would start just putting it on the picture, like 5x plus 11, 4, 3x plus 1, 6, 8x minus 19, and then 3x minus 14. Okay? And how are you going to solve for x? Yes. What do we set them equal to? So what kind of angles are those? The pink ones that I just wrote. They're exterior, and we have all of them. So what are they going to add up to? Yeah. So this is one expression for the total. That's long, but that's the one expression or one way we could get the total. And then the other side is the total, which is just 360. Okay? And then, like Bailey said, we'll simplify and solve. Notice that the question asks us for the interior angles. How are you going to get those? Alright, so x is 20. How are we going to get the interior angles knowing that x is 20?
You plug x into the equation, and then depending on what that is, since like 1 and 2 is a linear pair.
Yeah, good.
The names.
Linear pairs, right? So this is 111, so this would be 69, I guess. Good? Alright, let's do another one. These we saw kind of in our example yesterday, where it's just forming a relationship between a bunch of them and only gives you one or maybe two expressions. So if you look at this example, it was kind of like that. We were told some congruence and then only given two expressions plus some 90s. Okay? So I'm just trying to show you the way these problems can show up. First question is, are those interior or exterior? Those are exterior. So it splits our formula list into the Interior, exterior, that means we need exterior ones. And notice none of these have any x's in them. When you don't know something in math, what should you do? What should you label it, I should say? Just make one of them be an x. Okay? Do you want to try this one, or do you want to just talk through it? What's better? Well, I want to make sure you have time to work, so let's just talk through it. Do you see how the only expression we have is relating 2 to 3? So I would say 2 we could call x. It's kind of like our root angle, meaning everything is built on it. Okay? So 3 is x plus 30, so is 1, so is 4, so is 6. So you would just copy x plus 30 all the way around. And then what would we call 2 and 5? Yeah, so those would just be both x, right? And this is x plus 30, and there, it's hard to see there, and there, and there. Okay? So all 4 of those would be the same. Then you're just back to what we just did here. X plus 30, x plus 30, x plus 30, plus x, right? And then solve. Okay. All right. The measure, I do want, let's write one of these down, because I think this is one of the kind we haven't done. Yeah, sure. Well, yeah. It's fresh. Don't you still have lots of boxes?
3.
Yeah.
You only have 3?
Yeah. Well, we have 3 more. There's 6.
Okay.
So just do it on the piece of paper.
Just put it on the very back. I mean, you can put it wherever you want, but. You should have been a politician. Or, I guess you still could. I don't know why I said should have been.
I'm in my old age.
Yeah. You're just a good negotiator. Alright, so I need to borrow the number, so let's say 30. So start writing this, the measure, and actually before you do, let's just title this exterior angle solving, another one. So the measure of an exterior angle of a polygon is 30 degrees. How many sides? So it doesn't tell us what kind of polygon it is. That's our job to figure it out. So this is like you don't need to flip, I'll just do it for you. It's like this version. So we did each interior angle where we had to solve with an angle given and solve for n. So it's like that idea, except what is the right side of an exterior angle problem? Always. 360 over n. Right? It doesn't have all this n business that we have to get rid of. Not in the same way, at least. So, the thing you need to key in on this one is this word. What is a synonym for that word? 1, good. So, one. Look at your, if you need, look at your front packet. Exterior angle. How do we distinguish between total and the other version?
if it's regular or not. Or,
True.
Either the whole exterior or just the one
Each, yeah.
single
So,
exterior.
one, each, those are all the same kind of idea. By the way, I forgot to write the word regular, so let's add that word. Otherwise, this isn't going to work. Just stick it in there so that we know this polygon is regular. Okay, so the keywords telling us which formula to get are an or one angle and exterior. So what I need you to start kind of getting familiar with as you work today is, on that front page, how do you know which formulas to narrow it down to? So we have 2 interior, 2 exterior. And there's always going to be a keyword or two that will point you to the right one. So if it says sum of, total, altogether, those are our totals, right? If it says one, each, single, I mean anything that implies that we're talking about one angle. Now we're doing the 2 that have an N on the bottom. So, I don't like scrolling as much. There we go. So the keywords in and exterior point to towards that formula. Everybody see why? Does everybody see why? All right. So, identify the formula. That's step 1. Step 2, as usual, fill in what you know. What do we know? Out of the 2 things we could substitute for, what do we know? Is it the each exterior angle or N that we're told? It's the angle, yeah. Is 30 degrees, right? And then it says how many sides. We're trying to find N. Okay? So each exterior is 30. And then we have the other side. 360 over N. And then we just solve. How do we do that? How do you get N by itself? Doesn't it say 360 divided by N? So we want to undo that. Yeah. So this becomes 30N equals 360, and then what? So a lot shorter process. Both the exterior angle cases are way easier, I think, than the interior. Okay. I think I would like you, do you guys have a little margin on the left side over here? Or maybe here? What I want you to be able to write is just, you need to know that every time you see an angle question with polygon angles, your first question should be what? Yeah, is it an exterior or interior? And then is it total or each? So, do you have room to fit it at the bottom?
Yeah.
Yeah, okay, let's just put it there. I feel like that would help. Actually, I'm going to say it this way. to pick the right formula. Always ask. Okay. 1. Is it interior? I'm having trouble. There we go. Interior or exterior. 2. Is it total or each? And how do we make that stand out? Some big orange box, how about that? Do you feel like that would be helpful? Okay. All right, so you have your sheet. Let's go ahead and just do the rest of those.